Thank you, everyone. So I think the name kind of gives it away. So I should have thought of a better uh, title. But cool, let's get started. So my talk is about Go maps and something that I found that was kind of funny and interesting. And it should have been a Go Foundation stock now that I realized. But anyway, I'll go ahead. Um, cool. So, what am I talking about? So, this is from the maps documentation of Go. It says since the release of Go 1.0, the runtime has been randomized map iteration order. So, what happened before it was randomized was that people were beginning to rely on the stable iteration so that if you wrote tests, you always relied on the same. On getting the same key, so it would be something akin to an ordered dictionary in Python. So, okay, I believe you. You say it's random map iteration order. So let me go here. Cool. So here I have a map and I have three keys. And what I'm doing here is just incrementing every time a key is hit. Cool. Sorry. Yeah. So cool. I believe you. So the first key is hit an in high number of times. Okay, but you said it was random. So what is happening here? Um, so this is someone reporting an issue on the on GitHub saying that the iteration order. So there was different behavior with the Go compiler and the GCC Go compiler, and it was because someone was relying on a consistent map order, which was not true. So I want to talk about Hyrum's law, which is some engineer from Google who has his own law. That's really cool. So with a sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors will be dependent on somebody. And as always, I have a relevant XKCD. Cool. So, which means that because they said it was random, I relied that I believe them, and it is not random from what I can see. So, what is actually so then, if you go look at the issue more, there's somewhere in the corner someone commenting. It's not actually currently random, and when this is fixed, it will still not be random. It'll just be non-deterministic. And if you really want random, you'll have to do it yourself. So why should you care if it's random or not? Maybe you want to get pizza in different New York boroughs and you're always sent to the same borough because your map sends you to the same key. But it has real world implications. So someone in the GoNats client was always was depending on the random behavior, which was causing an imbalance. So it always sent to the same server uh, instead of distributing it across different servers. Cool. So what is really happening? So what happens here is that uh, the bucket size is 8. So if you only have and you get a pointer and then you choose some bits to say that this will be the bucket I choose, and you use some bits to say what's the offset of the bucket. So and you, each position has 8 buckets. So sorry we had only three keys in sorry we had only three keys in our map, which meant that every time you choose 4 or 5 or 6 or 7, it wrapped over. So you chose A with the probability of 6 by 8. So it's heavily biased towards 8. So cool. So I'll have more than 8 keys. And let's see what happens then. It's still disproportionate. I think we didn't learn a lesson when the guy said, if you have to make it truly random, do it yourself. Cool. So let's do that. So now I have keys, but then I also randomize them. And if I run it now. I have a fairly balanced map. Cool. Yeah. So there's also a lot of other Hyrum's law in the wild that have been seen. So one example is for Python Packaging Authority, where what happened was every time they released a new version of the package, they had a predictable URL and someone broke it. So there were people opening issues on GitHub and saying, "Can you just give us a predictable URL?" But they said, "This is not a contract that we signed up for. Maybe you should use something else." So if you have any other examples of Hyrum law, I would love to hear them. And yeah, that was my talk. And these are all the links that I used. Does anyone have any questions?
Question?
Yeah.
Up until your talk, I thought that map iteration was pseudorandom, so I'm probably wrong about this as well. But do you know if the select operator pseudorandomly selects receivable or sendable channels? Because I also thought that was true, but now I'm questioning myself.
I have no idea, but that's a good question. Yeah, you shouldn't trust people when they say it's random.
Anyone else?
Cool. Thank you
Cool,
so
thank you.
much.